All right, mathletes, here we are looking at the gradient function. So differentiation is the algebraic process used to find the gradient function. To differentiate the basic polynomials, okay, what we are going to do is from our function, okay, the gradient function is pulling our exponent, our n here in this case, and putting it out in front and multiplying it by n times a. And then what we have to do is we decrease that power or that index by 1. Okay? So the same thing, notice just this is a notational difference here. If we call this a function f of x, then the gradient function is f prime of x with that apostrophe there. Okay? This is valid for all values of n, including negative values. So let's look at an example here. So if I want to find my gradient function here, okay, dy dx, okay, this is equal to 4. I drop down my my exponent, so 4 times 7, and then it's x, and then I take this index, I do 7 minus 1. So if I simplify this, 4 times 7 is 28, and that's x. 7 minus 1 is to the 6th power. So this is my dy dx. Okay, let's look at another example here. So here, if my function is f of x is equal to 3x to the 5th, f prime of x, my gradient function, is 3 times 5 times x, and 5 minus 1. 3 times 5 is 15. We get x to the 4th. This is my f prime of x gradient function. Another example here. So, if we have multiple parts, okay, you just do each part, and those parts are an addition or subtraction. We can do each part separately, one by one. So f of x is equal to 3x minus 4x squared plus x cubed. So f prime of x equals, well, I get 3. Remember, there's an imaginary 1 here. So I do 3 times 1, and 1 minus 0, I get 1 minus 0 there. Or 1 minus 1, I'm sorry, because it was a power there. I'm always subtracting 1. Okay, which ends up being 0. But then I have, for the second piece, I have negative 4 times 2, and then it's x and 2 minus 1. Now, for the next piece, I have plus 3x and 3 minus 1. So now if I simplify this, I'm just going to get 3. X to the 0, this is just equal, that is just equal to 1. Anything to the 0 power is 1. So I get 3, and I get negative 4 times 2, so I get minus 8. X, 2 minus 1 is to the first power, plus 3x squared. Okay, so this is my gradient function f of x. All right, let's look at another example here. So I have f of z is equal to, so at this point 2 is just a divisor, so I'm going to pull that out as a factor, and I get 3 halves. This is z to the 4th. Okay, haven't changed anything, but this just helps me write it using my rule. So I get 3/4 times, or 3 halves, times 4 times z to the 4 minus 1. Well, 3 times 4 is 12 divided by 2, and I get z to the 3rd. Well, 12 divided by 2 is just 6, so I get 6z to the 3rd, and this is equal to f prime of z. Okay, another example here. So notice that this is a product of two polynomials, linear polynomials. Well, we can't just do it piece by piece because they're not a sum. So in order to differentiate this, we need to make sure that they are distributed first. So we're going to double distribute and get it into a standard form. So I get 3t squared plus 12t minus t minus 4. So when I simplify it, I get 3t squared plus 11t minus 4. At this point, since I have 3 different parts, 1, 2, 3, I can differentiate each part individually. So I get 3 times 2, t of 2 minus 1, plus 11 times 1, remember imaginary 1 here, times t of 1 minus 1, that will go away. And then minus 4, well, I don't really have anything here, so these constants here, okay, they just go away. Now this is now no longer there. It differentiates out. So then I have 6t to the first plus 11. 11 times 1. T to the 0 is 1, so then I'm just left with this. So note that make sure all your constants, when you differentiate them, they just end up going to 0. Okay? Alright, let's look at another one here. So this one is when we're dealing with a fraction. Our variable now is in our denominator. So what we want to redo is we want to write this as 4. I want to write it as a power and get it out of the denominator. Well, using my rule that I know 1 over x to the negative a is equal to x to the a, I can move it to the numerator by changing the sign of the exponent. So I can write this as 4 of x to the negative second. And because this differentiation rule works for both positive and negative, I can do 4y over 4x equals 4 times negative 2. And I do x of negative 2 minus 1. This is equal to negative 8 of the x minus 3. If I want to write it so it looks similar to our previous problem, I get negative 8 of x to the third. Okay, and our last problem here. Okay, so similar idea of division. So I'm going to rewrite f of x now without my x in the denominator. So I have 12/5. That's just my coefficient in front. And I have x to the negative third. Okay, so I have 12/5 times negative 3. And that's x to the negative 3 minus 1. Well, this is going to be negative 36 over 5. And I get x to the minus 4th. Again, if I want to rewrite this with the x in the denominator, I can do negative 36 over 5x to the 4th. And again, this is f prime of x. Okay, that concludes our notes tonight on differentiation of polynomials. Highlight any questions you might have and bring them to class.